Okay, so we're going to end up this week with a couple of case studies or scenarios for thinking about what kinds of comparisons we might need to make in different kinds of linguistic studies. Right? And these are all sort of ripped from the headlines. They're based on real linguistics research. And so I'm going to ask you to just think about uh, what an interesting alternative hypothesis might be and what kind of an interaction we're going to need to study in order to compare that alternative to the experimental hypothesis, right? And to be clear here, there's always going to be a number of possible answers to this question. That's why I'm trying to teach this stuff, because it's hard. There's no right answers. There's a lot of possible ways to formulate alternative hypotheses and to compare them to the experimental hypothesis. So we'll start out with this question about conservative determiners. And if you recall back a few weeks in my lightning overview of linguistics, I talked about conservativity in determiners as a part of semantics. And so conservativity is a particular property of the meanings of things like articles and quantifiers, things like every, some, the, a, and so on and so forth. That means basically that they place restrictions on their first argument but not on their second argument. It's not actually super important to understand all of the details of how conservativity works in order to do this exercise. Just know that it's a particular meaning property that all natural language determiners seem to have, but that it's not logically necessary for determiners to have. So there's sort of a mystery here. Why do we only find conservative determiners in natural languages if you can imagine conservative or non-conservative ones? If you want to be refreshed on what the conservativity is about, go check out the semantics section of the Lightning intro class. But here's the experimental hypothesis. Do English speakers have difficulty learning the meaning of novel non-conservative determiners? And then the next question is going to be, well, compared to what? So take a minute and think about this. Do they have difficulty learning this class of items compared to what? And there's a number of answers here. In general, the number of possible answers you could think of is going to be a product of the number of important constructs in here. So we have English speakers, we have learning, we have meaning, we have non-conservative, and we have determiners. And any one of those could be changed and we'd derive some kind of alternative hypothesis. And each of those alternative hypotheses would correspond to a particular kind of research question. So the one that we want to use is going to depend on the question that we're trying to ask. And doing this kind of exercise can help actually sharpen our understanding of what we're really trying to get at in the research. So if you change English speakers to, I don't know, Spanish speakers, we're going to get one kind of a comparison. Do English speakers have difficulty learning these items compared to Spanish speakers? That would answer some kind of a question about cross-linguistic variation, although this is probably not the one we'd want to ask in this experiment, because as we noted in that semantics overview, it looks like all determiners in possibly all natural languages are conservative, so there's no particular reason to think that English speakers would have any more difficulty with this than speakers of any other language. Here's another one, learning, I mentioned as a construct. Do English speakers have difficulty learning the meaning of novel non-conservative determiners? Well, I suppose you could try some other paradigm that goes beyond learning their meanings. Maybe it would be like using ones that already exist. The problem there, again, is that there don't seem to exist any non-conservative determiners. So that's probably also not going to be a good alternative for this particular hypothesis. That said, I'm just trying to illustrate you can change up any one of the constructs in this hypothesis, and you're going to get a minimally different hypothesis to compare it to that will attempt to answer some kind of a question. Which construct you're going to minimally change is going to depend on the specific thing you want to ask. And if we change one construct, what I mean by a minimal comparison is that we'll get a tightly controlled experiment where we're comparing two conditions that are the same except for the parameter of interest, whether that's the language of the speakers, the kind of learning versus usage activities. I mentioned meaning as a parameter here, so here's another alternative. Do English speakers have difficulty learning the phonological form of novel non-conservative determiners? That's again going to be asking yet another kind of question that would be slightly weird in this context because we don't think that the meaning of these determiners is really related to their phonological form, their sound pattern. Although you never know. There are associations between sounds and meanings in language. They're mostly arbitrary, but sometimes they're not, right? Or maybe processing difficult semantic material has a carryover effect on phonological forms. I could imagine some context in which somebody might want to ask about that alternative. That's not the most obvious one we'd want to change here, though. The most obvious thing we'd probably want to change here is the non-conservative part, right? Do English speakers have difficulty learning the meaning of novel non-conservative determiners compared to novel conservative determiners? And that would isolate what's probably the element of interest here, which is the conservativity property. Now we have two conditions that are roughly the same except for conservativity, and that's going to help us answer questions about conservativity, right? That said, you could also maybe think about this with other parts of speech. So do English speakers have difficulty learning the meaning of novel, non-conservative, ditransitive verbs? That is, verbs that take two arguments. That could be another kind of approach you might want to take. You'd have to define what conservativity means for verbs before you do this, but it might be possible to look at. In general, the most obvious thing that we probably want to alter here is the conservativity of the stimuli, but in principle, changing any one of these constructs will give you a different alternative hypothesis that will isolate a different factor or a different parameter in your research design. And we want to try to isolate the parameters that we're trying to learn about. So if this is an experiment about conservativity, we're probably going to want to change the conservativity aspect, but it might have been an experiment about cross-linguistic differences, in which case maybe we want to change the language of the speakers, or it could have been an experiment about something else. Okay, next example. Again, real life experiment that's been done. Are second language learners whose first language lacks a contrast between L and R type sounds. These are sometimes referred to as laterals and rhotics. Do language learners learning a foreign language whose first language lacks this contrast, are they slow to learn such distinctions in their second language? So maybe the second language here is English, right, which does have a distinction between L and R. Maybe it's like Russian or Spanish, which has a distinction between L and R. But whatever, these kinds of liquids. Other languages, such as Mandarin, Japanese, and Korean, do not have a contrast. Some of them have only one of these sounds. Some of these languages have both sounds, but never in the same context. They're not in contrast. And the question is, do learners whose L1 lacks the contrast have trouble learning it in L2? And the question here is going to again be compared to what? So take a minute and think about some possible comparisons that you might want to make here in order to isolate different aspects. So things you might want to change here. You could change, first of all, the phonetic content. We're looking at lateral rhotic contrasts here. And the question could be, are they slow to learn these contrasts as opposed to other contrasts in the L2, right? As opposed to the t versus d contrast, right? Is this one particularly hard? That would absolutely be a valid approach. It would be asking about the difficulty of this non-native contrast versus some other contrast, which might be either native or non-native to these speakers. And the question is, are they going to be slow to learn these things compared to what? Well, maybe it's compared to other contrasts. Are they slow to learn such distinctions in L2? Well, you maybe want to compare that, whether they're slow to learn, compared to being slow to use them, right? Or being slow to perceive them or something like that. That could be a question you'd want to ask. Maybe we already know that they have difficulties with these, and we want to figure out if those difficulties arise during the learning process or from perceptual properties or during the production process of being able to produce these distinctions. Are L2 learners slow to learn these contrasts compared to L1 learners? That one's going to be tough because most of the L2 learners are going to be older, where most of the L1 learners are going to be infants, right? But you can imagine in principle, maybe that's the question. Is it what's the effect of foreign languageness on learning this contrast? Again, the most obvious thing that you probably want to look at here would be some other contrast. But you could, in principle, change other constructs here, get other minimal comparisons that control for everything except minimally different parameters. And the final example here is taken from cognitive neuroscience and neurolinguistics, and it's just meant to illustrate how inherently difficult it is to study the neural substrates of cognitive things, and especially linguistic things. So here is the sort of experimental hypothesis or research question. Does listening to sentences with phonological errors increase hemodynamic activity in the superior temporal gyrus? Okay, so let's unpack this a little bit. I'm assuming you all know what listening sentences and phonological errors is. Well, phonological errors just means sounds that are not right, that are not the way that they should be produced in that context, or where people actually make mistakes while they're speaking and pronounce the wrong sound or something like that. Hemodynamic activity is the movement of blood, and that is measured indirectly in I think an MRI machine. They look at some kind of an index of electromagnetic activity that's meant to track how much oxygenated versus deoxygenated blood is moving around in a particular area of the brain. As you can imagine, that is extremely complex, just being able to make those measurements. An MRI machine, magnetic resonance imaging, is extraordinarily expensive, and of course it was invented for medical diagnosis, but it's now been increasingly adopted into trying to study cognitive neuroscience, where we try to measure what's going on in people's brains while they're performing various kinds of mental tasks. So that's going to be some kind of a measurement of brain activity. And the superior temporal gyrus refers to a particular area in the brain. The temporal lobe is one of the large parts of the brain, and a gyrus is a kind of like a valley. Or no, wait, that's a sulcus. What is a gyrus? I don't even remember. It refers to a particular anatomical feature of the brain, the superior temporal gyrus. And yeah, so this is going to be a question about whether some kind of particular mental activity, cognitive activity, namely listening to sentences with phonological errors, whether that increases brain activity in some particular area of the brain. And of course, you're going to need to have a compared to what question here. And there really are a number of different possibilities where some of them are hard to figure out. So take a minute and think about what you might want for a control condition here. Okay, so some sort of possibilities that are probably not what we're looking for, although who knows. Listening. Well, does listening to these sentences increase activity in the superior temporal gyrus compared to reading them? That could maybe be an interesting question, although it's not even clear what reading sentences with phonological errors would mean. I guess it would have to be something like spelling errors, so that's probably not what we're looking for here. Listening to sentences with phonological errors versus words with phonological errors? That could be a kind of interesting question, although, again, it seems unlikely that that's what we'd be interested in, at least at the first pass here. Listening to sentences with phonological errors versus listening to sentences without phonological errors? Well, now we're getting somewhere. So now we have a fairly minimal comparison. It's the presence versus absence of phonological errors in these two conditions. That's the only difference between them. So it allows us to isolate that factor. Or does it? Because this is what one of the big problems is with psycholinguistic work in general, and especially with neurolinguistic work, is anytime you create a difference between two linguistic constructions, because language is complex and multidimensional, you're potentially changing more than one thing, right? So if I put a phonological error in the middle of a sentence, and then I compare it to the same sentence without a phonological error, well, there's a couple things I've changed here. Yes, I've changed the presence versus absence of a phonological error, but I've also changed the probabilities of the words involved and the sounds involved in that sentence. I've changed how coherent it is in terms of meaning, right? One of these is easier to process than the other. I've changed whether it can be syntactically segmented easily or not easily, right? If you don't recognize the word, it's going to affect every other level of linguistic processing as well. And so even with this fairly minimal design, minimal control group, it's going to be pretty tough to say what's actually going on here. Now, in actual practice, a number of researchers who are interested in this kind of question actually take the entire construct sentences with phonological errors and change that to well, sorry, actually, I should have said that's not necessarily having to do with errors, but they'll compare a condition like this to a non-linguistic stimulus because they're not sure whether the difference here really has to do with the specific linguistic properties at work or just the fact that it's a well-formed piece of language to begin with versus not a well-formed piece of language. And so sometimes the control condition will be a bunch of random noise, maybe a bunch of random noise that has similar acoustic complexity to human speech, but is not human speech. Maybe it's silence, although there, again, you're never going to know whether the differences you're finding are due to the specific linguistic properties of your stimuli or the fact that they are sound as compared to no sound. Right? So there's really a lot of factors that need to be controlled, and it's quite difficult to do so. Right? Now, other constructs here, do they increase hemodynamic activity? Well, there could be alternatives there, whatever else you can measure. And so that could be a methodological investigation, actually, right? Versus, let's say, event-related potential activity, which you don't need to know anything about except that it's a different way of measuring essentially electrical activity in a region of the brain. Right? So that could be a methodological question. Is it easier to detect this signature with one measurement system than with another? Right? That's what you would get by changing the hemodynamic activity factor in this design. What about the superior temporal gyrus? Well, that would be a localization experiment. If we're interested in figuring out where phonological errors get processed, then maybe we want to compare that superior temporal gyrus to Broca's area or to the inferior frontal gyrus or something like that. These are all real brain areas, but I'm kind of throwing them out there randomly. I don't know which ones are implicated in which activities, at least not off the top of my head. But the point is, you might be interested in looking at that particular brain region instead of some other region. And all of these would be potential alternative hypotheses because neurolinguists and cognitive neuroscientists tend to be interested in all of these things to some extent, right? So the linguistic properties, the fact that it is language versus not language, the way of measuring brain activity, and the brain region, they often end up having to try all of these control conditions. And even then, we're not sure exactly what we've controlled for and haven't controlled for. So the point here is that, yes, experimental control is something to strive for, but the reason it's worth studying and thinking about is because it's hard, right? It is one of the hardest problems in empirical research is trying to figure out which things you need to compare in order to isolate the effect of interest. It's a very difficult problem, and the more sort of theoretical constructs that you have in your domain of study, the more complicated this problem becomes because you can imagine changing any number of constructs in any number of ways, but we're trying to keep relatively minimal comparisons.